Single phase motors. Single phase motors refers to a motor that's designed to operate on alternating current, comprises of a rotor and a stator. The rotor is the part of the motor that rotates when it is supplied with current, and the stator is the body of the motor that generates a magnetic field. The stator comprises of a starting coil and a running coil, or a main coil, and these coils are a necessity for the running of the single phase motor. The stator's windings are typically mounted at an angle of 90 degrees to each other. The universal motor operates on the principle of a rotating magnetic field. Different configurations of the motor will allow the motor to gain different properties. When it is activated, it has the ability to be connected in AC or DC depending on the configuration of the coils, typically a series configuration. The advantages of the universal motor is that it has a high starting torque, in other words, high strength of rotational force at startup. It can run at high speeds, and they are lightweight and they are compact, making them ideal for the use in power tools. Their disadvantage are that they still have commutators, slip rings and brushes, and as a result these wear out from continuous use. Second disadvantage is because of the commutators, they are typically very noisy. Now the construction of the single phase induction motor. As stated earlier, consists of two parts. First part is the rotor, the second part is the stator. The rotor is made up of, if we have a cross-sectional view of it, we will see the rotor has several conductive rods placed around the edge. These rods are connected at the front and the back end of the rotor by means of conductive plates. So when looking at this device, we will see those conductive rods connect through from the one side to the other side, something along that. There we've got the conductive rods, there we've got the end plates on the front and the back, and this is what a cross-sectional view would look like. And then there in the middle we've got the axis on which it rotates. The stator comprises of several different pieces. We've got the housing, that holds all the pieces together. And then we get all the different field coils, the same as we did with the DC machines. Now, the field coils again will be mounted on field poles, and this is what the actual stator will be. It's the field poles with their magnetic, with the electromagnets that will cause the magnetic fields. Now the example over here only has 2 pairs of coils. In practice we will have many more sets of stator coils and stator windings.